Hello everyone, welcome to Civil Mania. So in today's lecture, I'll be teaching about Risa 3D. So let me start with Risa 3D. So in today's lecture, I'll be telling about the design and analysis of a multi-story building. Let me design today for a building of height more than 10 story. So let me start. So as you can see here in my previous videos also I have told that this is my demonstration version, that is demo version. So in today's video first I will do with the let me go to the view. After going to the view I will switch off the project grid as well as I will go to the drawing tool and I'll switch off the display grid. After it has been switched off, now let me go to the home button and let me set with the units as everything is okay because I have set the standard metric units, so everything is okay. Now in today's lecture I will be telling the two important things, that is one is the template and the second one is the section set. What these two things are, because for drawing any kind of building these two things you must know. That is first let me go to the template. As you can see here there are various templates such as circular template, parabolic circular arch, parabolic arch, 3D grids, trusses, geodesic dome, cylinder plates, members, cone plates, circular disc plates, circular radius plate members, rectangular tank. So with the help of all these templates you can draw different type of structures. So as today I'll be designing with the multi-story building, so today I will go with the 3D grid. So let me click in the 3D grid. After clicking, as you can see here, this menu arises 3D grid template. So let me choose the origin. The origin by default is selected as 000. It's okay. After that, the node prefix, node is actually denoted by n. This one is also okay. Then there are the three planes x, y, y, z and z. These are capital letter, each means global axis. Now let me select the material. What kind of material I will be selecting for the plates? So remember that I will be only providing the plates to my building in my, that is the roof which is present in a building. I will be providing only the roof and the floor as the plates, and the walls I will, and the walls which are present in the building, those I will provide with the help of, as you can see here, this wall panels. I will be providing the plates only in the roof and floor, and the roof and floor are present in this axis as you can see here. So this one is the x z axis. So keep me only on the z axis and remove the other axis, because in the xy and yz axis I will be providing with the wall panels. I will be keeping only in the z axis the plates. So let me select the plates of concrete of M20. Thickness I will provide as thickness of the plates, that is thickness of the slab I will provide as 150 mm. So this one is okay. After it's okay, fluid load. Fluid is not required because this one is not my tank. So now place click on next. After clicking next, now the X axis member. Material, as you can see here the material is present. Let me select the material as the concrete. Then section set, this one is very important thing which I will show you, and you must remember this section set, because for designing any kind of drawing, if you are very clear with the section set, then it's very easy to select as well as to draw the building. So in the section set I will click in these three dots. After that I will click on view and edit existing. As you can see here, I will give the name of the level as this one is the x-axis. Remember that x-axis and z-axis, these are the two directions for the beams, and y-axis is the direction for the column. Here I will provide the name as beam x. Now shape is, I will go to here in the shape, and I will provide the shape of the beams of 300 mm by 250 mm. Okay, then this is beam, it's okay. Now rectangular beam, okay. Material, let me select the material of M20. Now let me even I can go here and I can give all these values different values, but as I have set M20, so everything is okay here. Now let me go to the design rules. I can edit here, and after editing I can set different values, such as what will be the minimum depth of the beam, what will be the maximum depth of the beam, what is the minimum width, maximum width, all these things you can set manually. Then what, how much is the deflection required for the different criteria. Then how much is the reverse, that is minimum reverse, maximum reverse, then shear reverse, then two leg stirrups is provided, then cover of 30, bottom cover of 30, side cover 30. You can also change this accordingly. So this one is okay. Now everything is okay. I have selected beam of 300 by 250. Okay, after that you need to concentrate on this part, that is number of increment. See, as you can see here, if I will be designing with these things, let me in the x direction keep as only two, and only two, that is in the x direction I have set the number of increments as 2, and of that is of panel length. Suppose one room is of 5 meter and the second room is of 8 meter. Okay, panel. Now let me select on the z axis. After that, here also I'll select the material as the concrete. Here again I will, this one is bmax, the previous one. Here I will click it, because there was only present one at the beginning, so I have edited this one. But now you cannot edit the same thing, because I have provided this section set for the x-axis. So now I will create another one. So let me create in the z-axis also beams are present, so I will write as beam z. Let me provide the beam of depth as 300, similar to the x-axis, and 250. Okay, now beam rectangular M20 typical, this one is also okay. Now in the z-axis, suppose I will provide the 4, that is 1 or 5, then 6, then 8. So number of increments are, so here let me suppose present here only 3 increments are present here. Let me keep as only the 3 increments. After that I have kept in this manner. Now let me select in the next. Now in the y-axis, this one is, I will also select the y-axis as the concrete, but this one is, I will here select as not the beam, but here I will select as the column. So let me click it here, create new. This one is column, because in the y-axis column is present. So I'll set the name as column y of let me provide the column height as 300 by 300. Okay, then M20, then everything is okay. Just I have provided here column, and this one is the section set. Now okay, see here there are three sections I provided: beam x, beam z, and in the y-axis it is column. Okay, now how much is the height I want? Suppose I will provide here the increment of 4. I can even provide here uh, suppose let me provide here a building of 10 story. I can provide here a building of 10 story. Then let me provide here a building of 10 story or 11 story. Then what will be the height? All I will keep it as 3 meter, 3 3 3, because height is kept as 3 meter, 3. Okay, after that I will click on yes. Now it will take a little bit time to get constructed. As you can see here, this is the building which got constructed. So after that, after the building got constructed, simply you can click it here, or you can go to the home button. After going to the home button, you can go here and you can select here as the rendered view. See, this one is the rendered view. After that you can like in this manner you can check the building whether it's okay or not. See, you can press the escape button and you can check here. See, in all the um, floors, the plates are being provided. Even in the bottom story, the plates are provided, which I have to remove it. So, as you can see here, the height of the building of 11 story, but only the problem is in the bottom floor also the plates are being present. So I have to delete these plates. So what I will do is I will click it here. I will delete the plates as well as I will click individual beams and I will delete it. This manner I will delete it. I will select and I will delete. I will click it here and I'll delete it as because by clicking in the individual member and pressing the delete button in the keyboard, it's taking a long time. So simply you can do it here. You can click in this delete single. After clicking it here, simply click in the members which you want to delete. This is how I have deleted all the beams and the plates present at the bottom floor. Now everything is being constructed. Now what you need to do is, now simply you need to go to the home tab, and there you have to select the boundary conditions. So now I'll provide the boundary condition. Click to. Now what I'll do is, now I'll provide here wireframe. After providing here wireframe, now I'll select all the, this is how we'll provide all the, you can see here. Now I have provided the pinned support to the fill building at the bottom story. After that, what you will do is, now you can again click it here for the rendered view. Now what I need to do is, now as the full building is being created with the frames as well as plates, now I will provide the uh, walls to the building. And for that, what you need to do is, I have to click on the wall panels. After clicking in the wall panels, I will provide the thickness of the wall panels as, let me provide the wall panels of 300 mm, and level name is this much, this one. What is the wall material? Wall material, let me select the wall material as the masonry, because walls are made up of masonry. Now material set is concrete. Let me click it here and click in the edit existing. It's okay, because wall material is masonry. Design rule also okay. Seismic rules not required. Now additional properties not required. Wall properties okay. Here you can even change if anything is required. After that, what I will do is create by clicking the grids not required. Now what I will do is, now I will simply provide the wall panels. And for that, what you will do is, similarly, let me click it here and here. This is how wall panels I have created. Let me create wall panels only to the bottom floor. You need to select only the diagonal points. In this manner it is created. Even I can create the, these are my, actually these walls are my, if something goes wrong simply delete it. Actually these walls are my load bearing walls. So if I need to make partition walls at between the center, then that also I can make it. How I will show you. So these are what I have created, the load bearing walls. Hope it's clear to all of you how I have created the load bearing walls. And for creating the partition walls, what you need to do is you need to simply go to the wireframe model. After going to the wireframe model, what you need to do is you need to simply click from here to the here. This one is the wall which I have created. Then in the similar manner, another wall created, another wall created. So this is how, as you can see here, even in the insides the walls are created. So hope it's clear to all of you how we have created interior walls. After that, after the walls are being created, let me go to the rendered model and check. Yeah. So it's clear to all of you how I have created the walls. You can see here. So I have placed the load bearing walls as well as partition walls in the ground floor. After that, as you can see here, the walls are present. Now I need to select all the walls by pressing the control button. You need to rotate. You simply press the shift button and the left mouse button to rotate it. After that, again rotate it. Now again press the control button and select whatever you want to select it. So as you can see here, I have selected all my wall panels. That is all my wall panels. Now what I will do is, now I will go to the modify option. After that, after going to the modify option, now what I will do is I will copy to all the floors, and for that what you need to do is you need to go to the global. After going to the global, here you need to yes, increment. See, the y increment will be at a height of, because our height is increasing by 3 meter, so I'll keep it at 3 meter. After that you need to place this one as on, otherwise you have to repeatedly do the process again and again, so you have to keep this tool active. After that, simply apply to select. Now after 3, provide 6, apply to select. Now 9, apply to select. 12, 15, 18, 21, 24, 27. As you can see here, the top floor which is present here is of different height. So up to 27 is okay. Now in the top floor, you can, because it's of different height, as it's of different height, let me do one thing. Let me either edit it or simply delete it, and for deleting, again go here and delete it. To check very carefully if so that no any kind of extra portion remains. Otherwise, error will appear. So in this manner, we have to. Else, you can also provide walls in this smaller also. So this is how we have. So this is how we have created the walls on the full building, as you can see here. Hope it's clear to all of you how to create the walls on the full building. After that, you can even do one thing. I will show you. Suppose there is the presence of doors or windows at any of the wall panels. What you can do is you can simply double click on the wall panel. Double clicking on the wall panel will arise. After that, what you need to do is you need to modify the opening, such as modify is there, opening is there. You need to make wall opening. Suppose I need to make a wall of this much height. This one is the wall I have provided. Similarly, this is the lintel. Suppose I want to make another one window here. So this is how we can provide the walls also. Sorry, openings, that is doors and windows in any kind of wall. After that, you can close this panel. So this is how we, as I have shown you, for a single wall I have shown you. If you want to create the same for all the walls, what you can do is you can copy this wall to all the floors in the similar manner by using the global. So this is how even we can create the openings in the wall. So hope it's clear to all of you how to create the openings as well as how to create the walls. After that, as you can see here, though the figure looks like that beams are not present here or some portions are not present here, what you can do is simply you can right click in the open space, go to the model view settings. After going to the model view, go to the wall panels, increase the size and apply it. Similarly, you can again go to the model view settings, go to the members, increase it, go to the plates, increase it. So in everywhere you simply need to apply it. After that, you can see the figure, how the figure it looks like. So this is how the building it looks like. So this is how the building it looks like. So hope it's clear to all of you how to create the buildings as well as opening. After that, what you can do is after that, after the creation of the full plan and elevation, now what you need to do is this is the 3D view of the building. After that, go to the home button. There loads are present. Before there the load are present, simply what you need to do is you need to go to the line load. And will apply the line load in the y direction. This is the global y direction. Always need to check this diagram if there is any kind of doubt. Y diagram. Now need to click it here and provide the description as here no description is present, so simply you can go to the load basics and provide here dead load. Now here provide here live load. Now provide here wind load. Now provide here earthquake load. No, will uh, will not apply here earthquake load, only dead load, live load, wind load. Then all these load are only present. Suppose I will prepare another one load, that is roof load. In my next numerical I will be applying for the seismic load also, but here I will not show you the seismic load. Okay, remember that this is Risa 3D software. Another one software is present of Risa, that is Risa floor planner. In that software you can very easily design the building. Like in this Risa 3D, it's very critical to design especially the buildings because it's time taking. But in the Risa floor planner, the process is very fast. Hmm. Even such as now I have taken 32 minutes, but in that software, it for this process which I have completed till now, it will take maximum 15 minutes. Sure, even I will show you about that software also, that Risa Flow Planner. So let me complete with this software first. So as you can see here, so I have created all these loads. Here I will, for the dead load, I will provide the factor of safety as 1, self weight. After that basic load is close it. Now let me go to the line load. After going to the line load, now I'll provide here y direction basic line load 1. Now what will be the magnitude of the what will be the magnitude for how much load you need to apply, and for knowing that what you need to do is you have to do the calculation part, that is you need to check the size of the beam, size of the floors. First of all, you need to apply for all the beams, then for all the walls. In this manner you have to calculate it. The calculation part I will show you in a different video. As I have shown very clearly, if there is any doubt in the calculation part, even you can go back to my stat pro playlist. There I have shown you the details of the calculation part in a very detailed manner. So if you want to go for the calculation part of the dead load, live load, that is how to calculate it, you can go back to my stat pro playlist. So here I will simply provide the load, that is start. Suppose I will provide the dead load of 25 kilonewton, 25 kilonewton in magnitude as well as magnitude. Okay, now I will apply the load distribution for the full length. Now I need to select all the beams, and for selecting all the beams, what you need to do is you need to go to this button. After that you have to select all the members parallel to x-axis. Select it. After that all the members parallel to z-axis. As you can see here, all my beams now got selected. Now what I need to do is I have to simply apply the load of minus 25 to the selected members in y direction. So I will apply it. See, as you can see here, now my load is mine. Now my dead load is being uh, applied in all the floors. As you can see here, this one is the load, this one is the load. In all the floors it got automatically selected. See here. So this is how I will apply the dead load. After the dead load is being applied, now I will apply the live load. Suppose I will apply the live load of 15 kilonewton. That again I have already selected apply to the selected. But before like applying, you need to go it here, and after going it here, just wait. Now we'll apply the live load. But remember that before applying, as I have made the mistake, what you need to do is before applying the live load, you have to simply click in this button and you have to select here category. That is in the category you have to select here as the live load category. Then apply it. After that, let me apply the live load of 10 in the selected member. Apply. Now even the live load is being applied. The dead load is also applied as well as this one is the dead load. Now I will show you the no, sorry, this one is the live load. Now I will show you the dead load. Preview the dead load. This one, these are the dead loads. Okay, so dead loads are present, live loads are also present. Now I will apply other load, that is now I will apply the plate load. Let me apply the plate load and it should be applied in the that plate load should be applied in the capital Y direction, and that one is actually the roof load. I will apply the magnitude of minus of 3 as per IS 456 2000. Now let me apply. Before applying, you have to do one thing. You have to click it here and you have to unselect all the members. After unselecting all the members, again go and click on the plate loads, roof load. Okay, click it here. Click in the category as the roof live load. Apply it. Now minus 3 category is being selected. Now you need to go here and select all the select here, because these are the, because you have to provide the roof load over the plates, so select all the plates parallel to X and Z. So let me select all. So these are all the, now you can see here all the plates are being selected. Now you have to simply apply to the selected. Now as you can see here, now the load is selected or applied in this manner. So hope it's clear to all of you how I have applied the roof load also. Now I need to apply the wind load. So go for applying the wind load, I have to go to the home button and I have to apply the wall surface load, because remember that wind loads are actually the lateral loads. So click on the wall surface, click in the wall surface, click here the wind load. Now wind load must be applied uh, in the positive x, positive y, positive z, and positive x, positive z, negative x and negative z. So let me first do the apply the load in the positive z axis. So let me select the global z axis. Let me select here the wind load. I have selected here the category as the wind load. Okay, apply it. Now uniform magnitude of minus of 5. per WinLoad code IS875 part 3. Now entire apply the load in the entire wall. Now I need to select it. Before selecting it, unselect all. I have unselected all. Now I can go there, wall load, Z, win load, okay, uniform 5, entire height. Now I need to select these walls, and for selecting these walls I need to yeah, click it here, and I need to select all the plates parallel to. Now I need to go to not the plates, but now I need to go to wall panels. Now all the wall panels parallel to, I am applying the load in this direction. So now it should be parallel to X and Y. X and Y. Okay. Now select it. Now as you can see here, now all my walls got selected. Now now my walls got selected. Now I'll write here as 5, because this one is the positive Z direction, so load will be applied in this manner. Now I'll unselect all this. Or let me do one thing. Let me apply. Hmm. Now I'll apply in these walls 5 entire or uniform wind load. Click apply to the selected. How it got selected, and always click the arrow. See, this is applied in this fashion. Is okay. Now you need to apply in these walls. After selecting this wall, now you need to apply, because this one is negative Z direction. Apply to the selected. Now it is applied in this manner. Now I need to apply the wall load in the X direction. This one is negative X. Negative X is this one. So negative X is this one. I'll apply the wind load in the X direction, applied to the selected. As you can see here, it's applied. Now I'll apply in this positive X. applied. This is how the load is now applied. As you can see here the arrows. Now the load is applied in this manner, in this manner, in this manner, and in this manner. So everything is okay. And now I have applied all the loads: dead load, live load, wind load, okay, and the roof load. Now after applying all the loads, now let me go to the basic load cases. As all the loads are present here, it's okay. Now go to the load combinations. After going to the load combination, click on load generator, and here you need to select the Indian load IS456 collapse load. Design is limit state of collapse. After that, notations, load options, X and Z also. No, keep it as none. Now let me go to the wind load. After going to the wind load, now you have to select the wind load in X and Z also. Generate roof wind load. Okay, roof wind load also generated. Generate semi-rigid diaphragm loads not necessary. Okay, now click on generate. Now it will generate all the load combinations, that is dead load plus live load, dead load, wind load, dead load in the positive Z direction and positive X. So in this is how all the load combinations are being created. Now you have to simply click in the solve batch plus envelope. Now just wait. Now the design calculation is being going on. Just wait for the moment till it's over. The design calculations. But it will take a little bit time because there are a lot of load combinations present here. Just wait for a moment. So this is how the node reactions are being calculated and everything are being calculated. Now you have the full results and you have to check whether if any red color results is present or not. Nothing is present here means everything is safe here. After that, let me go to the design part and concrete and concrete. Okay, it's okay because all our members are concrete. Now close it. After that, what you need to do is after that you have to simply click in the modify button and you have to check for the code model merge. You have to check for the model merge. Apply all. Do you wish to continue? Warning code is okay. The results will be cleared in. I now I need to again generate the results. See, 132 nodes are being aligned. Remember that model merge is very necessary because sometimes what happens, some nodes they doesn't get joined, then you have to merge those models, merge those models or joins. After that, what you need to do is After the model merge, I have done the model merge, all the results got erased. So you have to again click in the check the results. This one is the, if you need to check the results, you have to click it here. Okay, so all my results are now present here. Nothing is in red color, means everything is safe here. Now I can go to, these are all my data results, but these are all my results. These are my data entries, but these are my results. Now I have to go to the code check and concrete. In the code check, I have to go to the concrete beams, and I have to check if all the, see, these are my beams which have filled the design, because they are present in the red color. Now I have to again check whether anything is see, what I will do is, now I will simply click it here and I will right click it. After right clicking it, sort by absolute maximum to absolute minimum. Now as you can see here, these are my members which their design got failed. Concrete beams. So these are my concrete beams which got failed. Now let me go to the concrete columns. Even the concrete columns sort by absolute maximum to min. These concrete columns, there also results got failed. Okay. So finally our some of our members says their results got failed. So now what you can do is, in order to rectify all these results, what you can do is, you have to go to this suggested design. After going to this suggested design, they will give you that resolve this with the suggested design. Remember that this process is actually known as optimization technique. Actually, in this optimization technique, uh, the software itself, they with the economical sections, as well as the sections which are safer, they will provide those sections to the field members. So what you need to do is, you simply go to the code check. After you code checking, you will you need to check whether the members, their design is failed or not. After those designs are failed, go to the suggested design and click in the resolve with the suggested shapes. Members, masonry walls, wood walls. Okay, click on OK. Now I need to check again whether the member says, now they have passed the design or not. I have to check again. So this optimization technique is very important in the Risa 3D software. Still, let me check if my member says they pass the result or not. Concrete columns. Still, some member says are present. Those have not passed the result. Short. Okay. Concrete columns are also present. Concrete beams are also present. Now again I will do resolve with the suggested walls. Now they will do the design automatically, and they will provide the safer result for us. In this manner, optimization is done. This one is very important in Risa 3D. So these actually in this optimization technique, iterations are done. That is, now I am doing my second iterations, because in my first iteration some member says they have passed the design procedure. After that, in my second iteration, some of the other members will again pass the design procedure. So you have to perform this process till all the members pass the design. Only one member, that is one column, has not passed yet. Now again I will click it here. Now my beams are safer, but columns has failed the design. So now I am again doing for the columns. Still, I will show you my in the concrete beams. You have, I will show you if any member has failed the result or not. See, all the members is a passed the result, but in the columns some members have are still, they have not passed the result. I will show you. See, four members have not passed the result, and I can also show you those four members which have failed the result. Let me do one thing. Let me, I will show this process, or I will repeat this iteration afterwards. But before that, I will show you. Let me do one thing. Let me go to the view home. Let me go to the home. After going to the home, let me provide with the wireframe. After providing with the wireframe, click it here. Now I will show you the section set. Section set means they will give us, let me switch off this one. In the section set they will tell us, see, blue color is unassigned, nothing is unassigned. Green colors are all beams, red colors are all columns, the grayish color is horizontal braces and the vertical braces, nothing is present here. So only these three colors you can check here. Now let me go to the section set. In the section set also you can check here blue color, beam X, beam Z and column Y. They will also give you the names of the section set. You can check here. These are the column Y, these are the beam Z, and these are the beam X. So with the leveling you can also check here. So this tab is actually used for leveling. Now I can check for the unity check. Let me switch stop everything. Now everything is switched off. Now I will show you the deflected shape. Just wait for a moment till it get loaded. So this one is the deflected shape of the full building. Okay. Just wait for a moment. So as you can see here, this one is the deflected shape of the building, and I can also show you those members which have filled the results. As you can see here, in the let me show it in wireframe model. Those members which have filled the result. Then I will show you the one misses stresses at the top section, and I have to check for if something has failed. Nothing has failed because there is no red color present here. Again, one misses at the top of the plates. For the plates as well as for the wall panels, I have shown you. After that, we can uh, go here and check for the other values, such as I can go here and I can show you the shear force values. These are my shear force values for the full building. Then after that, I can go there and I can check for the moment values. These are my moment values. After that, I have switched off everything. I again switched off the one misses also for plates and as well as for wall panels. Yeah, as you can see here, even by clicking in this button, it will show you all the results. Now, what I can do is, now I'll again go to this results and I can check for each and every result. Such as I can check for the node result. These are my node results. Then these are my node deflections. Then street drift, member forces, member stresses, code check I have already done. Suggested design I need to do it. The last step I have, because one iteration I have not done. Seismic detailing. Then seismic detailing it will not show because I have not done any kind of seismic. I have not applied seismic load, so they will not provide us seismic detailing. Concrete reinforcing. They will provide us all the reinforcing, such as in the beams at the top, how many reinforcements and what are the reinforcements required. They will provide each and everything in detail for the beam as well as for the column. So everything is present here. I can even show you like how to find out the material takeoff. If you will click in this material takeoff, it will show you how much amount of concrete material required. This much kg total masonry is this much M20 this size of columns and beams. This much material is required. So this is how we can. And this one is the plate and whereas this one is the wall. So this is how it will show you how much amount of materials are required in total, in terms of volume as well as in terms of kg. This one is a very good option for material takeoff. Now I can also check for the connection results. I can go to the connection results and I can check for the member ends. But this one is for hot rolled steel, but our design is fully concrete, so we will not check for all these things. Now I can even go to this suggested where is my suggested design in the results. This one is my suggested design. I can click on the suggested design, or I can go to this results and I can go to the envelope and I can check here the suggested design. This one is my suggested design. I can simply click here. I can click here the suggested design, and they will again do the suggested design, so that my column now gets again safer. Again you need to click on this suggested design. Again check for the suggested design. Again they will solve it. You have to do till the column becomes safe. So this is how you have to do repeatedly in order to check the design. We'll check now how many members they are filling my results. So concrete columns. Again I will check it. So this is how we can do the design. So hope it's clear to all of you. If there is any kind of doubt, then you can ask me in the comment section. I'll try to clarify your doubts. And if you have not subscribed my channel, then please subscribe it, and share with your friends and colleagues. And if you like the video, then please like the press the like button, as it will motivate me. So thanks for watching my video. Have a good day. And before going, I will show you another one thing, that is the detailed report. You can also click in this detailed report to check for the detailed report.